Core 1, I wanted to make a video of the notes in case you were having difficulty filling them out on your own. So the second section of this chapter talks about functions as equations or different representations of functions. So you can find all these answers from the notes page that I gave you, or the textbook page, but I'm going to fill them out here in case you want to see it as well. So the first thing we have is a blank. A blank blank is an equation that describes the relationship between inputs, the independent variable, and outputs, the dependent variable. So this is called a function rule. So you're going to fill in function rule. So your input is the independent variable. This is what changes. That's why it's called independent. It can change. Your output is the dependent variable because it depends on what the input is. So you can't get your output unless you have your input. So we have two examples. We're going to write a function rule for each of these examples. So they give us the function in words, and we need to write the equation. So it says write a function rule for the output is 5 less than the input. So we know that our output is y. So it says the output is, that's our equal sign, 5 less than the input. So that means we're taking our input and we're subtracting 5 from it because it's 5 less than what you put in. So that would be our function rule, y equals x minus 5. The second example is write a function rule for the output is the square of the input. So again, we'll start with our y equals, the output is the square of the input. That means we're taking our input x and squaring it. So our equation is y equals x squared. If you move down, there's nothing to fill in here. This just gives you examples of functions as tables and graphs. So back to the tables and graphs. So we have already created function tables to graph equations when we do linear equations. So the table and graph below represent the function y equals x plus 2. So if you look at the table, here they came up with their inputs, 1, 2, and 3. When they plugged it into the equation, 1 plus 2 is 3, 2 plus 2 is 4, and 3 plus 2 is 5. So that's how they got their ordered pairs. They then graphed their ordered pairs, and it says by drawing a line through the points, you graph all the solutions of the function y equals x plus 2. So that was just a recap of how to graph an equation, which in this case, they're functions. On the textbook page, there was an example of that if you wanted to take a look at how to graph it. We also know how to graph using the slope and y-intercept, so you have plenty of tools and are already familiar with graphing. So let's take a look at a real-life application. It says the number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by the car. Write a function that describes the relationship between G and P. So if we go back, I'm going to underline some important things. It says the number of pounds P produced by a car is 20 times the number of gallons G. So I know in my function P is going to be equal to, because it says P is 20 times the number of gallons G. Well, 20 times tells us to multiply. So 20 times G is represented by that function. So our function is P equals 20 times G. So however many gallons you have, you would multiply it by 20 to get the number of pounds of carbon dioxide produced. Again, if you look at the textbook page, it then goes into you making an input-output table and graphing it, so you can take a look at that if you would like. So we have taken a function written in words and written it as an equation. We've come up with that function rule, and we've also done it for word problems. So now you can go ahead and do the practice problems on the second worksheet I gave you. When you get to the graphing questions, you could just draw me a little sketch. You don't have to actually draw out the entire graph. So just use your y-intercept, use your slope, and kind of give a sketch of what the graph would look like. Hope this helps.